Phosphine gas is a term you might not hear every day, but it's incredibly important, especially in certain industries. This gas, though not commonly discussed, plays a crucial role in various applications. However, its significance comes with a set of risks that everyone should be aware of. It's a colorless, flammable gas. This means you can't see it, making it even more dangerous because it can be present without any visual warning. In laboratory settings, scientists handle it with extreme caution, using specialized equipment to detect and manage its presence. It has this fishy or garlicky smell. This distinctive odor can be a critical clue to its presence. If you ever catch a whiff of something that smells like garlic or fish in an industrial setting, it could be a sign of a phosphine leak. You might not even know it's there until it's too late. This is why awareness and proper detection systems are vital. Workers in industries where phosphine is used must be trained to recognize the signs and symptoms of exposure. That's why it's important to understand phosphine and how to stay safe around it. Safety training sessions and equipment demonstrations are essential in educating workers about the potential hazards and the necessary precautions to take. Phosphine is used in a few different industries. Its applications range from agriculture to electronics, making it a versatile but hazardous substance. Each industry has its own set of guidelines and safety protocols to manage the risks associated with phosphine. It's used as a fumigant to protect stored grain from insects. In agriculture, phosphine is a valuable tool for pest control, ensuring that stored grains remain free from insect infestations. However, this use requires strict adherence to safety measures to prevent accidental exposure. It's also used in the semiconductor industry. Here, phosphine is utilized in the manufacturing process of electronic components. The cleanroom environments and advanced technology in semiconductor factories help mitigate the risks, but the potential for danger still exists. Even though it's useful, phosphine can be really dangerous. The very properties that make it effective in various applications also contribute to its potential for harm. Proper labeling and the use of protective gear are non-negotiable in environments where phosphine is present. That's because it can quickly poison you if you breathe it in. Inhalation of phosphine can lead to severe health issues, including respiratory distress and even death. Immediate medical response is crucial in cases of exposure to minimize the impact on health. We'll talk more about that in the next section. Understanding the dangers and learning how to protect yourself is key to working safely with phosphine. Stay tuned as we delve deeper into the safety protocols and emergency procedures in the upcoming sections. Phosphine is toxic to humans and animals. It interferes with our cells' ability to use oxygen. This can cause serious health problems. Exposure to high levels of phosphine can be deadly. It can cause fluid buildup in the lungs. This can lead to respiratory failure. Even low levels of phosphine exposure can have effects. You might experience headaches, dizziness, or nausea. Long-term exposure can damage organs like the liver and kidneys. Phosphine can be found in a variety of places. It's important to be aware of these environments. Grain silos and storage facilities are major areas of concern. Phosphine is used to fumigate grain. This prevents insect infestations. However, it also poses a risk to workers who may be exposed. Industrial settings that use phosphine are also potential hazards. The semiconductor industry, for example, uses phosphine in the manufacturing process. Proper ventilation and safety protocols are crucial in these environments. Phosphine detectors are essential for detecting the presence of this dangerous gas. These devices are designed to alert us before phosphine levels become dangerous. Electrochemical sensors are commonly used in phosphine detectors. These sensors work by detecting the electric current produced when phosphine reacts with a specific electrode. When phosphine gas comes into contact with the sensor, it generates a signal. This signal is then amplified and displayed on the detector. The reading tells us the concentration of phosphine in the air. Section 5. Fixed versus portable detectors, choosing the right tool. There are two main types of phosphine detectors, fixed and portable. Each type has its own unique features and benefits, making them suitable for different scenarios and applications. Understanding the differences between these two types of detectors is crucial for ensuring safety and efficiency in environments where phosphine gas is present. Fixed detectors are designed to be permanently installed in specific locations. They are ideal for areas where phosphine gas is consistently present or likely to be present. These detectors are often used in industrial settings, storage facilities, and agricultural environments where continuous monitoring is essential. The primary advantage of fixed detectors is their ability to provide continuous, real-time monitoring of phosphine levels. They are equipped with sensors that can detect even the slightest changes in gas concentration, ensuring that any potential hazards are identified immediately. When phosphine levels exceed safe limits, fixed detectors can trigger alarms, alerting workers to the danger. This immediate response is critical in preventing exposure to harmful gas levels and ensuring the safety of everyone in the area. Portable detectors, on the other hand, offer a different set of advantages. These handheld devices are designed for flexibility and mobility, allowing workers to carry them as they move through various areas. This makes portable detectors ideal for tasks that require frequent movement or for monitoring multiple locations. Portable detectors are particularly useful in situations where fixed detectors are not practical or feasible. They provide on-the-spot readings of phosphine levels, enabling workers to quickly assess the safety of their environment. This is especially important in dynamic or changing work conditions where gas levels may fluctuate. Additionally, portable detectors can be easily calibrated and maintained, ensuring accurate readings at all times. They are an essential tool for workers who need to ensure their safety while performing tasks in potentially hazardous areas. In conclusion, both fixed and portable phosphine detectors play a vital role in maintaining safety in environments where phosphine gas is present. By understanding the strengths and applications of each type, you can choose the right tool for your specific needs, ensuring a safe and efficient working environment. Section 6. Calibration and maintenance. Keeping your detectors sharp. Just like any other safety equipment, phosphine detectors need regular calibration and maintenance. This ensures that they are functioning correctly and providing accurate readings. Calibration involves exposing the detector to a known concentration of phosphine gas. This is done to make sure the detector is providing accurate readings. Maintenance tasks include cleaning the detector and replacing any worn-out parts. Regular calibration and maintenance are essential for reliable phosphine detection. Section 8. Automated safety features, an extra layer of protection. Many fixed phosphine detection systems are equipped with automated safety features to provide an added layer of protection. These systems are designed to detect the presence of phosphine gas, which is highly toxic and can pose serious health risks to workers. By continuously monitoring the air quality, these systems can quickly identify any dangerous levels of phosphine and take immediate action to mitigate the risk. These features may include alarms that sound when phosphine levels reach a critical threshold. The alarms are designed to be loud and clear, ensuring that all workers in the vicinity are immediately alerted to the danger. This prompt warning allows workers to evacuate the area quickly and safely, reducing the risk of exposure to the toxic gas. They can also activate ventilation systems to clear the affected area. The ventilation systems work by rapidly exchanging the contaminated air with fresh air from outside, effectively diluting the concentration of phosphine gas. This not only helps to protect the workers, but also prevents the gas from spreading to other areas of the facility. Some systems can even shut down equipment or processes that may be contributing to the phosphine leak. By stopping the source of the leak, these systems can prevent further release of the toxic gas, thereby minimizing the overall risk. This automated shutdown feature is particularly important in large industrial settings where manual intervention may not be feasible in a timely manner. These automated responses help to minimize the risk of exposure and prevent accidents. In addition to protecting the health and safety of workers, these systems also help to ensure compliance with regulatory standards and reduce the potential for costly downtime and repairs. By investing in advanced safety features, companies can create a safer and more efficient working environment for everyone involved. Section 9. Staying safe with phosphine. Best practices and early detection. Working around phosphine requires vigilance and adherence to safety protocols. Always be aware of the potential hazards and follow proper handling procedures. Use appropriate personal protective equipment, including respirators, when working in areas where phosphine may be present. Early detection of phosphine leaks is crucial. Regularly inspect and maintain phosphine detectors. If you suspect a leak, evacuate the area immediately and contact qualified personnel to assess the situation. Remember, safety comes first.